Hello, second period, seventh period, and eighth period. This is a little factoring review. I can't be here in person, but I'm here in the smartboard. Kind of cool stuff, if you ask me. Hey, here's how this is going to work. We're going to have our presidents, Natalie, Dylan, and Damon. They're going to run the smartboard for us, okay? What you're going to need, your notebook, you're going to need a calculator, and a pencil, perhaps some highlighters, okay? So what we're going to do is I've got several problems for you to try, and you're going to go through the video. And when I tell the president to pause it, you're going to pause it, try to do the problem, factor it completely, like on the first couple, or solve it if there's an equal sign. And then you're going to get to see my solution so you can check and see how you're doing. So let's go ahead and pause the video, try to factor the first one here completely, all right? If you're still watching at this point, I'm assuming you've all tried it, given yourself enough time to do it. So we're going to group. How do we know to group? Well, Julia Glogi can tell us that there's 4 terms, so we're going to group. All right, and let me see here. So I'm going to factor out a GCF, which is going to be an M, right? And that doesn't look much like an M. I guess that's a little bit better. So I'll have M times the quantity of A minus 6. And I'm going to factor out a negative 2 here, I believe. How did I know to do a negative 2? Well, I looked at my A term in this quantity. And by the way, my mouse is slightly possessed here, in case you're wondering. It's bouncing all over the place. That's a positive A. Well, if I don't factor out a negative 2, I don't get a positive A. So I'm going to factor out the negative 2, and I'll have that times the quantity of A minus 6. Ooh, I like that, because now I have another common factor. Remember, factor by grouping means we're going to GCF 3 times, usually 3 times, every now and then 4. There's an A minus 6 here and an A minus 6 there. All right, so we're going to have the quantity of A minus 6 times the quantity of M minus 2. And that is done. All right, that's an A. I know it looks a little bit like a 9. I apologize. This mouse is just driving me nuts. But as far as things go, I'm very grateful to have this piece of technology and to be able to come to you even when I'm not here and hopefully show you how to do things. All right, so number 2, go ahead and pause the video. Hopefully everybody has made a real attempt on it. I'm going crazy with this mouse, but here we go. All right, first type of factoring I should always look to try is GCF. And I see a 5x hiding in here. So I'm going to factor out a 5x. And I'm going to factor out a 5x, right? And so I'm going to get a 5x times the quantity of x squared minus 4. Now I'm not done factoring, because that thing in the quantity can be factored further. Now you have 2 choices. You can do the difference of perfect squares, because it's a perfect square minus a perfect square, which is a really easy way to do it. But if you don't do that, if you don't see that, you can do the ABC thing. Now remember, when I do ABC, I'm only looking inside the quantity. The 5x has already been factored out. It stays in the problem, but I don't use it to factor any longer. So that was kind of cool. Easy as 1, 0, negative 4. I multiply A times C, but I'm gonna think about it as a positive 4 when I do it, just because there's less factors to deal with. All right. So I need 2 factors of 4. Let's subtract to get B. Let's subtract to get 0. I'll bet you Angela Demchuk can tell me that would be 2x minus 2x. And so I'm going to have the 5x times the quantity of x squared plus 2x minus 2x minus 4. And there we go. And now I'm ready to do some grouping, right? I'm going to group these 2. Going to group those 2, always grabbing that negative. It doesn't look like I did a good job of grabbing that negative. Maybe I'll rewrite it in there. All right, so I'm going to factor out, well, here I'm going to have this 5x out front. I really should have a bracket there. I'm going to factor out an x, that's the GCF, and I'll get an x plus 2. I'm going to factor out a negative 2, and I'll be left with an x plus 2. And then, there we go. Now there's one more GCF, right? So I still have the 5x. I'm going to jump over here, so I'm out of room. 5x. Okay, I'm going to bring out an x plus 2, and I'm going to be left with an x minus 2. Okay, that's a little bit of a long way to do it, but it works. Now, for those of you that wanted to do it by the difference of perfect squares, well, you would take the square root of this, and you get x, and you take the square root of that, and you get 2, and then it would factor the same way. You'll have the 5x out front, and then remember, you have to have two quantities. That's a mistake some of you are making. Put the square root of x squared in the first place, and the square root of 4 in the second place, and we should all know that square root of 4 is not 2, it's 2 or negative 2, and so you see I get the same answer regardless of the way I do it. Okay, let's look at the third problem. All right, there it is. Go ahead and try it. Pause the video, please. Okay, here comes my solution. I'm going to look to GCF. It looks like the GCF is 7. I'm going to factor out a 7. And when I do that, I get 7 times the quantity of w squared plus 9. And I'm done. This is not the difference of perfect squares. Why? Difference implies subtraction, right? There is no subtraction in this problem. So I can't factor this any further. Some of you thought it was going to be w plus 3 in a quantity times w plus 3 in the quantity. Can't do it. I'm recording! So when you double distribute that, you're going to get a positive 9, but you're also going to get a 6w. There is no 6w in this problem. Well, some of you say, well, I'll make it one of each. And if you make it one of each, the problem is, sorry, that mouse is really acting up. You don't get a positive 9. You get a 3 times a negative 3, which is a negative 9. So you see, this can't be factored. This is done. It's not prime because we pull a 7 out, but the w squared plus 9 part is prime. All right, number 4, I need you to solve it. Not just factor, but solve it. So, Mr. or Madam President, please go ahead and pause the video. Here comes my solution. I see no GCF in here, so I'm going to go right to A, B, C. Easy as 1, negative 13, 12. I'm going to multiply 8 times C and get 12. And I need two factors of 12 that add to get negative 13. And remember, the plus in the back means it's a Wendy's double stack. So this plus in the back here means I'm going to need two negative numbers to get my 13. I'm just trying something to see if I can make the mouse work better. Pardon me 1 second. Ooh, yeah, that is working better. Wow. Okay, just shutting it off and turning it back on. Go figure. All right, so I need two factors of 12 that add to get negative 13. Well, how 1 and 12? And they both have to be negative. How did I know that? Because there was a plus in the back. I need B sign, right? So now I'm going to rewrite this as x squared minus 1x minus 12x plus 12 equals 0. So I'm going to have x times the quantity of x minus 1, pull out a negative 12, and x times x minus 1 in the quantity, And then there's a GCF. The x minus 1 is common, so I'll pull him out front and have an x minus 12. And then I will have equals 0. Now I'm not done because there's an equal sign. I have to have two equations. I'm going to have x minus 1 equals 0 and x minus 12 equals 0. All right, going to solve. I'm going to get x equals 1, and I'm going to get x equals 12. What the hookah waka is that? All right, doesn't look like an equal sign, that's for sure. All right, equals 12. Okay, and my solution set would be 1 and 12. That means if I put either 1 in for x in this equation, I will get 0. Or if I put 12 in for x in the equation, I'll get 0. Okay, one more like that. Go ahead and pause the video. That is an 18 there. Okay. Here comes my solution. First thing I'm going to do is factor out a GCF. I think a 2x is going to be my GCF. I'm thinking all of them have a common factor of 2x. I'm recording! Sorry about that. So I'm going to pull a 2x out front. And I'm going to have a 9x squared minus 24x plus a 16. That's going to equal 0. Now, inside the quantity, I can do my ABC thing, or I can do a perfect square trinomial. I'll do it both ways for you. So we'll start off with A, B, C, easy as 9, negative 24, 16. Okay, multiply A times C, and I'm going to get 144. Now this is the long way to do it, but if you don't recognize this perfect square trinomial, it works really well. All right, now I need two factors of 144. Ooh, that's gross. That will get me 24. Well, I know it's going to be 12 and 12. Right? I could do the square root thing and I'd get 12, and look at that, 12 times 12 is 144. There's a plus in the back. It's the Wendy's double stack. They're both negative. Okay, so I have 2x, and then I'm going to have a 9x squared minus a 12x minus a 12x plus a 16. That'll equal 0. The 2x stays out front. I'm going to GCF this pair. I probably should show the grouping here. Let me show the grouping. There we go. And so I'm going to get what? A 3x. And what will be left in there? A 3x minus 4. And then I'm going to pull out a negative 4. And I'll have a 3x minus 4. And then that'll equal 0. I have the 2x still out front. I'm going to pull out the 3x minus 4. And what will be left? A 3x minus 4. That'll equal 0. There you go. Okay, so now I have to do two equations and solve. So I'm going to get rid of this work just because it's in my way. And this really isn't a hard problem, but there's an awful lot of steps. I totally agree. I'm going to have 2x equals 0. I'm going to solve for x. So x is going to equal 0. And then I'm going to have 3x minus 4 equals 0. And I'm going to solve for x. I'm going to add 4. I get 3x equals 4. And then I'll divide by 3. And I'll get x equals 1 1/3. So my solution set is 0, and then 1 1/3, right? Okay. The other way to do it would have been going right to a perfect square trinomial. I would take the square root of this, and I get 3x. I take the square root of 16, and I get 4. Now I have to multiply those two and get 12x. And if I double it and match that, which I do, if I multiply by 2, 12x turns into 24x, then it factors real easy. That 2x is still out front, right? But there's going to be two quantities. Better get rid of that 144. It appears to be in my way. Okay, and so I'm going to have a 3x and a 4, a 3x and a 4. There's a plus in the back. It's the Wendy's double stack. They're both negative. Boom, because b was negative. And then I could solve it. I'm not going to solve it again because it's the same solution. All right, here's another one. This one's a little different. The product of two consecutive odd integers is 1,763. Write a quadratic equation and solve it by factoring to determine the two integers. All right, go ahead and pause the video, see what you can do with that. Here comes my solution, and I'm going to try to shut off again. I think what's happening is my power is low. I've got it plugged in, and as I turn it off and then turn it back on, it like has a little bit more power, and then I'm able to use it for a little bit. All right, first I'm going to define my variables. I don't know what the two consecutive odd integers are, so I'm going to make them up. I'm going to let n be the first of the consecutive integers. And then the second one will be n plus 2 because they're odd integers, right? So it'll be the second of the consecutive, and it should be odd, technically, odd integers. Wow, we're really having some problems here. Okay, so I need to multiply those because it tells me the product. So I do n times the quantity of n plus 2. and that's going to equal 1,763. Hey, this looks like a rectangular problem, doesn't it? Yeah, looks just like it. So I'm going to distribute and get n squared plus 2n equals 1,763. I don't want it to equal 0, or 1,763. I want it to equal 0. So I'm going to subtract 1,763 from both sides. And when I do that, I'm going to get n squared plus 2n minus 1,763 equals 0. And I apologize, that one number is just so hard to read. I'm really having some fits here. Normally I don't have this many problems. Minus 1,763. That looks a little better. All right, so now I've got ABC. A, B, C. Easy as 1, 2, negative 1,763. Multiplying A by C, I get 1,763. Now instead of listing all the factors of that, I'm going to take the square root of 1,763. When I do that, I get about 42. It's pretty darn close to 42. Right? Now, I need to move equidistant from 42. Well, B's distance is 2, so the two factors of 1,763 that I'm subtracting, because C is negative, have to be 2 units away from each other on a number line. So from 42, I'm going to move 1 unit away. I'm going to go up 1 unit and get 43. I'm going to go down 1 unit and get 41. And then I'm going to test it. What is 41 times 43? 1,763. By the way, you just found the numbers. You just have to finish the algebra. Okay, so there, one's going to be positive and one's going to be negative because my C is negative. I see B is positive, so I want the larger of the two to be positive. And so we have a negative 41n and a 43n. All right, so we're going to have, wow, n squared plus 43n minus 41n minus 1,763. I'm getting sick of saying that number. Now I'm going to group. Okay. Grabbing that negative, very important. Putting an operator between so it doesn't turn into a multiplication problem. So I'm going to factor out an n and get an n plus 43. And then I'm going to pull out a negative. What negative do you think I'm going to pull out? Well, I bet you I'm going to pull out a 41. How do I know that? Because n is just one n in this first quantity. So I'm going to pull out a negative 41. That'll leave me with an n, and that'll be a plus 43. That'll equal 0. So I'm going to have the quantity of n plus 43 times the quantity of n minus 41, and that'll equal 0. And then I'm going to solve, right? And when I do that, I'm going to get n equals negative 43. But I'm also going to get n equals positive 41. Now, I have two answers, but they're two different answers. Those are n. I need to know what n plus 2 is. Well, n plus 2 is going to be negative 41, isn't it? If I add 2 to n, and n plus 2 over here is going to be 43. There's actually two sets of answers. It could be 41 and 43, because if I multiply those, I get 1,763. But it also could be negative 41 and negative 43, because if I multiply those, I get positive 1,763. All right, finally, last problem here. Let me give a little more room. All right, you're given a prism, and you're given the volume of the prism. Go ahead and pause the video, and let's see what you can do with it. All right, I'm getting ready to show you my solution here. Let me get my mouse turned back on. All right, connection, there we go. Oh dear, strange, it keeps reverting that. Okay, the first thing I do is I set up length times width times height is volume. So I'm going to do 9 times 5x minus 3 times 2x plus 1. And that's going to equal 54. Now, Remember, we talked about it in class yesterday, hopefully in all the classes, but the first step here, a good first step might be to divide by 9. That's what I'm going to do, because if I divide by 9, it's going to look an awful lot like other problems we've done before. The 9s will cancel. I'll be left with 5x minus 3 times 2x plus 1, and that's going to equal 6. Yeah. Okay, now I'm going to double distribute, and I'm going to get 10x squared minus 6x plus 5x minus 3, and that's going to equal 6. I'm going to simplify 10x squared minus x minus 3 equals 6. And then I'm going to set it equal to 0. So I'm going to subtract 6 from both sides. All right, in doing so, I will get 10x squared minus x minus 9. That will equal 0. Uh-oh, must have run off the page. There we go, the airliner. Now I'm ready for A, B, C. And that's going to be easy as 10, negative 1, negative 9. Multiplying 10 times 9, I get 90. I need two factors of 90 that subtract, because C is negative, to get negative 1. Well, how about a 9 minus a 10? So I rewrite this as 10x squared. If I were Megan Tick, I would probably rewrite it like a minus 10x, because the 10 goes so well with the 10. And then she would put a plus 9x, because the 9 goes so well with the negative 9. Right, she talked about that in class on Tuesday, and Megan, I got to tell you, you were so well prepared. I mentioned in class I was very proud of you. All right, and Pooja, you know I'm very proud of you for how you came into class on Monday over the weekend. I could tell you had done a lot of work, buddy. Keep it up. All right, now I'm going to GCF this first quantity. I'm going to pull out a 10x, and I'm going to get x minus 1. And then I'm going to pull out a 9, and I'm going to get an x minus 1. All right, then I'm going to pull out an x minus 1. Oh, that doesn't look like an x minus 1. Sorry about that. I'm going to rewrite that. Ah, I thought I put myself in eraser mode. Silly. Let's try that again. All right, I got to tell you, I'm glad this video is just about over, because this mouse is driving me crazy. What's going to be left here? A 10x. What's going to be left here? A 9. And that equals 0. So now I'm going to solve for x, and I'm going to get x equals 1. And I'm going to get x equals negative 9/10. Okay, so now I'm going to go back to the original problem. And I got x equal to 1. So if I put 1 in for x, I get 5 minus 3. I get 2 inches here. Of course, this stays 9 inches. And this becomes, x is 1, that would become 3 inches. And 2 times 9 times 3 is 54. Inches times inches times inches is inches squared. So that works really good. So I know this is a valid solution. And when I do that, I have, what, 2 by 3 by 9. So my answer is 2 inches by 3 inches by 9 inches, right? Now, when I put the negative 9/10 in, let's see what happens. Negative 9/10. Oops, I went too far. Sorry. Negative 9/10. I might not be able to do this one in my head so well. Well, if I put a negative in here, 5 times a negative is going to be a negative. Minus a negative is another negative. I'm going to get a negative dimension. So I'm going to throw this answer away. But I always want to check, because you never know when there's going to be a positive coming out of a negative x. All right, so my solution is this. X is 1, and the dimensions of the rectangle are 2 inches by 3 inches by 9 inches. All right, that's it for the video. Hopefully you got through it all. Mr. Lawrence signing off. Have a good night, everybody.